Dr. Daniel Barth here with the University of Arkansas Astronomy for Educators program. Today, we're going to show you how an eclipse works. A lot of times I have people, teachers, students come up to me and say, I know the eclipse will have the sun going dark, but what's really happening out in space? How does it work? Does the sun turn off? No, that's not true. The sun is a nuclear furnace. It was ignited about 4.5 billion years ago, and it has enough fuel to keep burning for another 4 to 5 billion years. The sun certainly isn't turning off. But like any light, its glow can be blocked. You can stand in the shadow. And if you're in the shadow, of course, sunlight doesn't fall on you. We're all familiar with this when we walk in the shadow from a building or under a shady tree, but how does the eclipse work? How does something cast a shadow from out in space? One of the best ways to show this is to use a model. And today, we're going to model a solar eclipse with a flashlight and a baseball. Now, the flashlight, like the sun, glows and shows out light. Of course, the flashlight only shines in one direction. The sun shines in all directions. But the moon, like our baseball, is a dark body. It doesn't emit any light. Now, it so happens that the moon occasionally passes directly in front of the sun. So if we're seeing our bright flashlight as the sun, if our dark baseball moon slowly moves in front, now we see the light is blocked. Our flashlight sun has been darkened. But as the moon continues to move in orbit, it moves away from the solar disk and the sun shines again. It's not a matter of the sun being shut off, but rather blocked. The shadow for the moon is very narrow. This shadow comes from the moon and it tapers to a point. This happens because the sun is a much larger body than the moon. So some of the light comes past the moon at an angle, and its shadow is shaped like an ice cream cone. It comes to a point. And it comes to a point just about at the surface of the Earth. So for this eclipse, the moon's shadow is going to be 60 to 70 miles wide, depending on where you are. And that shadow will draw a line, called the line of totality, across the United States, from the coast of Oregon, diagonally southwest to the coast of South Carolina. Now, this eclipse that's coming across our country will be visible to everyone in the United States. Everyone in the United States will see at least a partial eclipse. For the exact time the eclipse happens near you, you'll need to consult an eclipse guide. There are many available, and you can use your favorite search engine to find them. For those of us here in Northwest Arkansas, our eclipse will begin at about 11:35 to 11:40. I'd recommend you start observing around 11:30 to make sure you don't miss anything. The first event will be called first contact. That will be when the moon just begins to block a little bit of the sun's light. You'll see, if you're looking at at the sun safely with solar eclipse glasses or with an eclipse projector, you'll see that it appears that there's a little nibble, a bite, like a bite taken out of a cookie. There's a little bite out of the solar disk. And this bite will continue to increase as more and more the moon covers the solar disk. For those of us here in Northwest Arkansas, we'll see about a 92% coverage of the sun, which will maximize around 12:40 in the afternoon, but between 12:40 and 1 o'clock. For exact times, again, you'll want to consult an eclipse map. Consider that, please, these times are approximations. As good as our mathematics is, where you are and where the eclipse maxes out depends on all sorts of factors. Your distance east and west, your exact location north and south, your altitude. There's a lot in there. So consider all times to be an approximation and start observing early if you want to see everything. When the eclipse happens, we're going to see this marvelous celestial event where the moon blocks the sun's light for just a little bit. Totality or maximum eclipse will last only a couple of minutes, and then the moon will begin to move away and we'll get the bright light of the sun again. So why don't eclipses happen every month? This eclipse, like all solar eclipses, is happening at the new moon. Why don't we have one every month? We have a new moon every month. It turns out the reason for that is simple too. The moon's orbit is tilted. Instead of the moon orbiting the Earth perfectly in line with the sun, it's tilted about 5 degrees. Now you might think, gee, 5 degrees is a very small angle, and that's true. But our moon is 250,000 miles, 385,000 kilometers from the Earth. So when you take a 5-degree angle and stretch it over 250,000 miles, the distance is quite a bit. It turns out that most months on new moon, the moon either, because its orbit is tilted, either passes above the plane of the sun or below the plane of the sun. Only when you have the moon passing exactly through the plane of the sun at the new moon, those two events have to occur together. That's the time when you get a total eclipse of the sun. I hope this helps, and I hope you're going to have fun observing the Great American Eclipse of 2017. Observe safely, and I'll see you when the sun goes dark. Thank you, everybody.